So a set is a collection of objects. The objects in that set are called elements of the set. We typically denote a capital letter as a set. So you can see here, P represents the set of all primary colors. And we have red, we have blue, and we have yellow. Here's some examples of sets. We have colors of a rainbow, states of matter. Order does not matter. So we have 1, 2, 3, 4, 5. That's the same as 3, 5, 2, 4, 1. The order doesn't matter because the elements in the set are still the same. Okay, to show that a set is infinite, we can use an ellipsis. Did you guys know that a dot, dot, dot is called an ellipsis?
Yes, I did.
So here we have an example. Prime numbers. Did you know that 1's not a prime number? What does it take to be a prime number? It's only divisible by itself and 1, right? But 1 actually is not considered to be a prime number. I don't know, I don't make the rules, but it's not. So 2, 3, 5, 7, 11. But there's an infinite number of prime numbers, right? So we use the dot, dot, dot to show that it goes on. What do you think it means when we have a dot, dot, dot on both sides? Yeah, so integers are all of the counting numbers and their opposites, the negative ones. So that shows that it goes on to the left forever and to the right forever, up to positive infinity. If on the test I ask you to give me the set of all integers and you don't put the dot, 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 that's going to be wrong. Because what are you saying if you don't put the dot, dot, dot? And I ask you to write all integers. Yeah, you're telling me that the only integers are negative 2, negative 1, 0, 1, and 2, but is that true? No, so you're creating a false set, a false statement by doing that. So make sure you use those when necessary. Okay, now we learn about something called a subset. So this is the next blank on your notes. A set is a subset if all of the elements of that set are also in another. So subset sounds kind of like smaller, right? Where it's like a set of a sample maybe of something else. So if I give you the example, it says B is a subset of A. That means that all of the numbers in B are also in A. So do you see that that's true? Bless you. So all of the numbers in B are also in A. There's more in A, but all of the ones in B are in A. So this is a blank on your notes, but this is how we write that. B is a subset of A. It looks kind of like a horseshoe with a line under it. So fill that in. Now, if I said it backwards, is that a true statement? A is a subset of B. No. Now, you have to be careful because a subset isn't necessarily always smaller. If I said C is 1, 2, 3, and D is also 1, 2, 3. Is everything that's in D also in C? Yeah, so D is a subset of C, even though they're exactly the same. And what could I say it backwards now? Yeah, because everything in C is also in D. So C is also a subset of D. So you could actually write it both ways in this case. So D is a subset of C, and C is a subset of D. Okay?
You just flip the horseshoe, or you have to write it out?
It's usually right from left to right, kind of like an inequality sign. You've actually seen this. You guys remember earlier? It's been like 3-4 months at least, probably. You remember seeing something like this? Yeah, it's a type of Venn diagram. So if I said A is the set of all birds, so every single bird, that's the set that I'm talking about. And B is specifically talking about cardinals, eagles, and blue jays. Are all of those birds? Yes. So I would say that B is a subset of A. B is a subset. Could I say that backwards in this case? Are all birds cardinals, eagles, and blue jays? No. And then you can see in our Venn diagram, why do you think B is smaller?
It's a smaller population.
Yeah, it's a smaller population of all birds. So B is inside of A because everything in B is also in A. And then do you remember what that stands for, like the box around it? Yeah. The trains and the Kayleys and the planets and everything else in the world. Okay, the next thing we have to talk about is something called a sample space. And a sample space is a set, exactly what we just talked about. It's a set of all possible outcomes of an experiment or an event, something that's happening. So if I ask you, what are all the possibilities of tossing a coin? Heads or tails, right? So I would say that's the set of heads and tails. So you can fill that in there. So tossing a coin, there's two possibilities. So there's two elements to our set. There's heads and there's tails. Okay, what about rolling a standard 6-sided die? Exactly. It's the set of the numbers 1, 2, 3, 4, 5, 6. Now kind of get used to writing the curly brackets, because anytime you're listing stuff, you're going to put them in those curly brackets to show that you're listing a group of things. And then C, drawing a marble from a bag that contains 2 red, 3 blue, and 1 white. You have to list everything that's in the bag. Yeah, you can put R, R, B, 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 W if you want. But you have to list everything that's in the bag. Any possibility that I could draw out of that bag, you have to include that in your set. So red, red, blue, 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 white. All right, so this is probably 100% new for most of you. There might be 1 or 2 of you that have seen this before. But now we're going to learn about something called an intersection and a union. And you need to know these signs. So this means A and. I want you to write that down. I know it's in the sentence, but I want you to write it above it as well. If you ever see a horseshoe that's upside down like that, that means and. And I'll write it over here to the side so that you can see it. So A and B. This means and. You really don't even need to remember that that's called the intersection. I just want you to know that that's and for now, okay? And the union, that's easy to remember. It looks like a U. But more importantly, that means or. So if you ever see this, they're saying A or B. Bless you. So let's do our 2 examples that you have on your notes. What are the numbers? So I'm going to read this out loud. What are the numbers that are in sets A? And what does this mean? And they're also in B.
9, 5, 6, 7.
So what numbers are in A?
3, 9, 15.
And they're also in B. Exactly right. It would be 3, 9, and 15. You guys see that?
Yeah.
We put it in the little.
Yep. 3, 9, and 15 are in both sets. So another way, and is asking you, what do they have in common? If they're in this and that, that means they're in both sets. So what numbers are in common? Okay, now the other one is the next example. It's A or B. So let me ask you this. Let me ask it this way. Is the number 1 in A or in B? Yeah, it's in A, right? Is 15 in A or B? Yeah, it's actually in both. Is 0 in A or B? Yeah, so what happens when I put an or in the middle?
It's all.
It's all of them, exactly. So you can see here, the 2 answers. A or B, you got to list them all. So, nope. Does order matter?
Nope.
No, so if you ever see an and sign, you're asking yourself, what do they have in common? And if you ever see an or sign, you're going to combine them both. You have to include everything, because if it's in this or that, it could be in either, right? So a Venn diagram is a visual representation of how things are split. So let's look at this Venn diagram. So it's the factors of 12 and the factors of 16. Why do you think these are in the middle.
Zero.
Yeah, is 16, does 16 divide by 1, 2, and 4?
Yeah.
Does 12 divide by 1, 2, and 4?
Yeah.
Yeah, but does 12 divide by 8? No, so that's why they're on their own specific sides, right? So let's answer number 1. What are the elements of set A?
1, 2, 3, 4, 6, 7.
So let's say A equals, then put a bracket. So anytime we're listing elements, you have to use set notation. Do I include 1, 2, and 4?
Yes.
Yeah, because 12 is divisible by 1, 2, 4. So 1, 2, 3, 4, 6, 12. And then pretty easy, what's in B? Good. 1, 2, 4, 8, 16. And we kind of talked about number 3. It's in the middle because both are divisible by those numbers, or they multiply to be those numbers. Now, real quick, I'm going to give you a little heads up. Count how many numbers are up here?
6, 7, 8.
8, right? But how many numbers did we just list down here?
12, 11.
11. Why don't those match? If I'm listing all the things that are up here, why don't they match, Ryan?
Because they're repetitive, because you had to put both in each set.
Does that make sense?
Wait.
Okay, lock that in your brain, and I'll come back to that in just a minute. I just wanted to plant a seed. Okay, number 4. What's in A and B? A and B. What are the numbers that
1, 2,
12
4.
and 16 divide by? 1, 2, 4. And what numbers are in A or they're in B? Tegan? All of them, right? Every single number in there is divisible by 12 or 16. So I'm not going to do that right now, but you can list all of those out. 1, 2, 4, 3, 6, 12, 8, 16. All right, so we're talking about 2 things here. We're talking about kids that are in the chorus or the choir, and it says, let the chorus be set A. So we'll call pink A. And band is B, so students that are signing up for band. Okay, now let me show you, don't write this down, this is wrong, but let me show you why. So how many students are there? There's 60. And then what happens is usually say, okay, well there's 21 in chorus, there's 29 in band, there's 5 in both, and there's 15 that are not in either. So I'll put that out in the open space. Now add those 4 numbers up. What do you get?
You did 65.
60. Total.
70. Good job, you guys. Proud of you. You get 70. But I thought there were only 60 people.
Because,
So, I'm going to erase these. And I'm going to tell you this. It's always easiest to start in the middle. So, for sure, how many are in both? 5. We know that for sure, right? So, we already talked about the ones that are in common go in the middle. Now, how many people sign up for chorus? 21. But we've already counted 5 of them. Because these kids are in chorus and band. So if they're in chorus and band, are they in chorus? Yeah, so we need to count them. So we need to take 21 and subtract the 5 we've already counted. So it'd be 16. Does that make sense? So now, look at the whole pink circle. What does that add up to? 20. The pink circle needs to be 21. Okay? So how many would be signing up for band if we know 5 are in both?
4.
Exactly. And the ones that are not in either are the ones that are not in either. There's nothing tricky about that. So now that we have this information, we can answer our questions. So the first question asks, how many students are in A? What does that mean? Or in B?
Well, it would be like...
How many are in A or B? No.
5.
Oh yeah, sorry, it's 45, yeah. So 16 plus 5 plus 24 is what?
45.
45. Good. Now, if you didn't do the Venn diagram, usually people do 21 plus 29 plus 5. But can you see how that's